we're going to work the even problems for anyone who feels like it would benefit them. If you want to work on your own, actively work. If you finish it, I think the answer key is posted in Canvas, so you should go check it before you scan and turn it in. And if you finish it, you can work on ALEC. All right, so some things I need to remember, my guys that are working with me. Number 2, we're looking at number 2. So Diane, you working with me? Brooklyn's working with me? Kendall, you working with me? Darian's working with me? Annabelle, you working with me? Danielle, Swan, y'all working with me? Okay. Jeremiah, Xavier, y'all working with me? Anthony, you working with me or on your own? Okay. Naya, you working with me? Okay. All right, so y to the 5th power, all raised to the negative 4th power. So there's a couple things we said about when to do what. When we see powers to powers, we always do those first, right? The other thing we said was we don't move our negatives until the very end. So we know the first thing we're going to do, and we should know the last thing we're going to do already. The first thing we're going to do here is we're going to take this y to the 5th power and raise it to the negative 4th power. What does a negative exponent tell us about this expression? What do we know about it just seeing the negative 4? Do you remember, Diane? What's a negative exponent tell us about that expression? It's going to be a fraction, right? So let's make it a fraction. All expressions technically are fractions because I'm over 1, right? So now, power to power. What is the shortcut for power to power? Is it add, subtract, multiply? Say again? Multiply, that's right. So y to the 5th power raised to the negative 4th power, we're going to multiply those exponents. So we're going to have y to the negative 20th power over 1. Can we have a negative exponent in our answer? No. So what do we do to make the exponent positive? Do you remember scenarios? Do you remember, Annabelle? What do we do to make the exponent positive? Yeah. In the top, we bring it down. Annabelle said bring it down. So since this is the top, we bring it to the bottom. If we're in the bottom, we move to the top. So for our answer, I'm going to put this in my answer blank. The y to the negative 20th goes to the bottom and becomes a positive 20. What do we say at the top if we don't have anything left in the top, Xavier? You're following me, but you don't have your pencil in your hand. If you don't have anything left in the top, what do we put up there, Xavier? Yes. So this was power to a power. There are 2 exponents, basically right next to one another. One way I was trying to get you to remember up high, multiply. That's what a teacher that I had back in the day would say. So this one and this one technically could be said it's a little bit higher. Usually it's a little bit higher. So we multiply those. But number 4 is b to the 6th times b to the 5th power. Is this a power to a power expression? It's a power times a power, right? But not a power to a power. So that's the difference. This is a power raised to a power. This is a power times a power. So the shortcut here is different. So the shortcut, if you have like bases that you're multiplying, you can add the exponents. So this is going to be b to the 6th plus the 5th power. The answer for number 4 is just b to the 11th power. Any questions? All right, so for number 6, 3 times y to the negative 5th power raised to the negative 3rd power. So is this a power to power problem or like base times a like base problem? What do you think? Brooklyn? Is this a power to power problem or are we multiplying like bases? Sorry? So look at this one. This is a power raised to a power. This is a like base times a like base. what does this one look more like? Power to a power or like base times a like base? Yeah, there's an exponent and another exponent right there. So that's a power to a power. Now, what's the part that's going to trip people up? Do you guys remember? I keep telling you every time we see this. Perfect. So Daniel said put a 1 as an exponent for the 3, or something close to that anyway, right, Daniel? So that's 3 to the first power. We do that because when we don't do that, kids forget to raise that 3 to the negative third power, right? So now, this would be 3. Remember the shortcut for power to power is multiply. 1 times negative 3 is negative 3. And then this is y. Negative 5 times negative 13. I'm sorry, negative 3. So that's positive 15. So 3 to the negative third power times y to the 15th power. What does that negative exponent tell us about that expression, Jeremiah? What's the negative exponent tell us about this? Jaden just said it a second ago. Jaden, will you remind him again? Means it's a fraction, right? So 3 to the negative third in this expression tells us we need a fraction to work with. So up here, look up here, Jeremiah. When we had this negative, we moved it to the bottom and made it positive, right? So what are we going to do with this negative? Yep. Where are we going to move it to? And is it going to be positive or negative 3? Yep. So remember, negative, once we move it, it becomes a positive. The whole point of moving it is to make it positive. All right, so that's going to be a positive 3. Now, this y to the 15th power, is that going to move or stay, Kendall? Y to the 15th power, stay in the top or move to the bottom? Yeah, positive exponents don't get moved. So now, we're almost done, but we need to evaluate this exponent. That just means we need to plug that. If it's a number raised to a power, we have to plug it in our calculator. So y to the 15th, we should be able to plug 3 y to the x3 equals, so make sure you know how to use that, because I'm not going to be able to explain this to you on the test. Every time we do these assignments and go over them, I explain how to use your calculator. I can't tell you how to do it on the calculator during a test. So what's 3 raised to the third power, Jeremiah? Perfect. Any questions so far? So guess what? This worksheet is going to look exactly like the test. Tomorrow's worksheet is going to look exactly like the test. Monday, when we come back from the holiday, that worksheet is going to look exactly like the test. You can literally, had you not done anything else this unit up to now, just work these problems with me, ask questions. You could learn all of this based on these 20 problems that we're going to do for 3 days in a row. All right? So let's not, if you've been discouraged, let's turn the page, right? Let's make an effort to learn how to do these 20 problems so you can start out with a good grade in Unit 7, okay? So a times b to the negative 5th power times a times b to the 4th power. Brooklyn, is this a power to power or multiply like base times like base? Perfect. Multiply like base times like base. Now here we have A, B, A, B. So remember, it's like base, A times A, and B times B. However, there is a power to a power here. So it's going to be like bases times like bases at the end, but first we do have to do this power to power. I kind of tricked myself there, Brooklyn, because there's no exponents there, right? And we have to remember those are 1. So we're actually going to do a power to power, and then a like base times a like base. So that's the tricky part here. So we do the power to power first. I'm going to bring along what I'm not going to do right now, that first factor. Now this is a to the first power raised to the 4th power. So what's the exponent on the a going to be? Gladys, what's the exponent on a going to be? A to the first power raised to the 4th power. What's it going to be? Not 5. The power to a power. Up high we multiply. Right? So 1 times 4. Is that on? 4. That's right. Now, so what is the equal 1 times 4, right? All right, so now, remember these parentheses, they're grouping symbols, so it doesn't really matter. This is a times b to the negative 6 times a to the 4th times b to the 4th. We could rearrange them, and we did that when we first learned how to do it. But really all I need to know is it's going to be a times a, like base times like base, and like base times like base. So remember, what is the exponent on the a if you don't see it answered? All right, so a times a to the 4th, what's the power on a going to be? Very good. So right here, this is like base times like base. We're adding the exponent. So it's a 1 plus 4 power, and then the b to the negative 5th times b to the positive 4th, that is negative 5 plus 4. So that simplifies, like Diane said, a to the 5th, and then this will be b to the negative 1st. So is that what's going to go in my final answer? No. Annabelle says no. Why not, Annabelle? Beautiful. We have a negative exponent. So what are we going to do if we have a negative exponent? Put it over 1, and then we're going to move our negative, right? I'm going to go ahead and put that in my answer blank. What am I going to do with a to the 5th? Does it stay in the top or does it go to the bottom? It stays in the top because it's positive. And so b to the negative 1st, is it going to stay in the top or go to the bottom? Go to the bottom, and it's going to be negative 1st power, Brooklyn? Positive. And I'm not going to write that one, right? Any questions on number 8? So, one more time. 2, 4, 6, and 8 are going to look almost exactly the same on all 3 review worksheets and then on the test. Okay? Typically, when we make these review worksheets, we take the test and we just switch the numbers of each problem. Should I be telling you that? Maybe not, but we're halfway through the year almost, and you guys have seen that the review worksheets look exactly like the test. These, I just think you could literally learn this unit just in the review worksheet. Yes, Bill?
Why you didn't put the negative 1 at the bottom?
I put the positive one at the bottom, right? But we don't want to put the 1 in there. So when we move it to the bottom, it becomes positive, right? That's the only reason to move it. Does that make sense? So this is b to the negative 1. To make it positive, we move it to the bottom. Okay? But I don't want to put the 1 there. So somebody asked me, would I take points off for that? I might. I might take a half a point off if you put an exponent of 1 on something. I might not, but you should not have that in your final answer. Just like you shouldn't have a 1 here, right? There should not be 1 a to the 5th, b to the 1st power. We should not have those 1s. Technically not wrong, but that's not how we write them. Okay? All right, number 10. Number 10, I see an exponent and raised an exponent. An exponent raised an exponent. Right? So we're going to start, we always say we start by doing the powers of powers. So what is the exponent on the 4 going to be? Xavier, what's the exponent on the 4 going to be? Am I going to add, subtract, or multiply the exponents here? Yes, power to power multiply. So 2 times negative 1 is 4 to the negative 2nd power. What's the tricky part on this factor? Did you remember? Daniel answered this question before. What's the tricky part on this factor? Sorry? Can't hear you. Yeah, well, there's an X. That's not the tricky part. What's the tricky part? Swan, do you think? Yeah, so there's the exponent on 3 is 1, right? If you do, for some reason, when there's not an exponent there, kids forget that has to be raised to that 2nd power 2, right? So that's going to be times 3 to the 2nd power. X, what's the exponent on the X going to be? Son? What's the exponent on the X going to be? Look at here. No, 4 times 2. It had a 4 on there, right? Yes. So, I have a negative exponent, so it can't be my final answer, right? So what are we going to do, Severian? What does the negative exponent tell us about the expression? You know, we're going to say number one, negative fraction. Negative exponents tell us it's there's a fraction. All right, so now my final answer, well, no, not my final answer. What am I going to do with the 4 to the negative 2, Kendall? I can't have a negative exponent, so how to make it positive? Like on the bottom, that's right. You move them. If we had a fraction that was on the bottom, we can move it to the top. Right? If they're in the top, we move it to the bottom. That makes it positive. So I give myself my fraction back. It's going to be 4, and now to the second power, 3 to the second power, x to the 8. And now this is where I have to plug in on the calculator my numbers that are raised to a power. So 3 squared on your calculator, that's 9 times x to the 8th power, and 4 squared on the bottom is 16. We do have to have a simplified fraction, so if you're not sure if that's simplified, you said 9abc 16 equals. I will tell you this one is simplified. But on the test, that's what you do to check. If you do 9abc equals and it's a mixed number, you hit second as abc again and we'll turn it into an improper fraction. That's the form we needed. All right. Questions on number 10? All right, let's do number 12. 6 times a to the negative 6th power over 12 times a to the negative 9th power. I think that's division, right? So, what is 6 divided by 12? What is 6, if we had to simplify 6 12, what would that be? 1 half, yeah. And remember, if you're not sure, it's 6 ABC 12 equals, and it'll tell you on your calculator that's 1 half. So we have a fraction already, so I'm going to keep a fraction for now. The next thing I'm going to do is when we divide like bases. So 6 and 12 don't have like bases. That was 6 to the first power, 12 to the first power, not like bases, but we do know how to simplify that fraction. Now, a to the negative 6th and a to the negative 9th, those have like bases. To divide those, the shortcut is to subtract the exponent. So a to the negative 5th power minus the negative 9th power. It's not minus 9, it's minus whatever this is. If this is a negative, if you do that on your calculator, what do you get? I think Annabelle's doing hers. Yes, positive 4. So for problem 12, it's going to be 1 times a to the 4th power. I'm not going to put that 1 because I still have something up here, over 2. So when I subtracted them, I took it out of this denominator. Now, if I subtracted and it's negative, then I would move it again. Does that make sense to Darian? All right, so we're going to go to 14. Anybody have questions on 12 before we go to 14? All right, 14 has the powers to powers. That's what we're going to do first. What's the exponent on 5, Jeremiah? 1. So, 5 raised to the 3rd power, x to the 4th raised to the 3rd power. We get one factor at a time. What's the exponent on the 5 going to be, Gladys? Sorry? What's the exponent on the 5 going to be? That's 2. 1 raised to the 3rd power, right? We multiply those. Power to power, we multiply. Yes. Now, x to the 4th power raised to the 3rd power, what's that exponent going to be, Diane? Sorry? Here, we're raising x to the 4th to the 3rd power. 12, yes. Now we have, remember, an exponent of 4. So that's times 4. 1 times negative 2, that's a negative 2 power, power to power. And x, what's 0 times any number? 0. So that's 2, 0. So what's x to the 0 power What's x to the 0 power, Danielle? Sorry? Yes, very good, 1. So now what we have left is 5 to the 3rd power times x to the 12th power times 4 to the negative 2nd power. What does the negative exponent tell us? What's the negative exponent tell us, Sidarian? Sorry? What does the negative exponent tell us if we get the end here? What do we need to do? What do we need to do, Jeremiah? Do you remember? If it's a if we see a negative exponent here at the end, what do we need to do? We are going to move it. Do we have a fraction yet? So we're going to put it over 1, and now we can move it. Okay? So 5 cubed positive doesn't get moved. X 12 is positive, that doesn't get moved. But the 4 to the negative 2nd power, in order to make it positive, we have to move it from where it is. Since it's in the top, we move it to the bottom. So for 14, so 5 cubed, you're going to do that on your calculator. 5 y to the x3 equals, now it's the time to learn how to do it on your calculator. 125. Please don't ask me on the test. Part of your lesson. You have to know how to do this on the ENC on this calculator. So I'm telling you exactly how to do it. The 12th power, right? And the denominator, 4 squared, is 16. You may want to put that in the calculator and make sure that it's simplified. That's 125, ABC 16 equals. It's going to give you a mixed number. Hit second ABC again, and you'll see that it actually is simplified. So you have to do that there. All right. Number 16. We learned a shortcut. If we have a fraction raised to a negative power, the whole fraction is raised to a negative power. We're going to do it in a minute. I'll tell you it's population divided by area, land area. Okay. You forgot your times 10, right? Times 10 and divide. Close, but not quite. Okay. Number 16. Does anybody remember the shortcut? Remember a fraction raised to negative power? Can you give me a problem like that? Kind of? No? Yeah? What do we do with the fraction raised to a negative power? Do you remember it? Yes, very good. Flip the fraction and make that exponent a positive. So that would really simplify our work a little bit if we just go ahead and do that first. I'm going to raise this part because I'm out of room here. You guys are looking below, I'm sure. Okay, so remember, a fraction raised to a power, we can split that fraction into top and bottom raised to the same power. So that's the same as e to the 6th power raised to the 3rd power over the denominator 2c to the 4th power raised to the 3rd power. So up I multiply. Please use your calculators if you're, just to double check, it's super fast on the test. Use your calculator. What's the exponent on 2 there? Not on 2. It's a 1, right? So we're going to raise it to the 3rd power. So 2 to the 1st power raised to the 3rd power is 2 to the 3rd power. It's 12 on the C. Right, so be careful because that 4 only goes to the C, not the 2. That's why we keep pointing out that the 1 is actually the exponent there. And then C to the 12. So for number 16, nothing to simplify in the numerator. 2 cubes on your calculator, you should find that it's 8 C to the 12. Any questions for me? All right, we're going to do 18 and 21, and then we'll let you guys look at the odd one. 18. Scientific, well, these actually aren't in scientific notation because this is not between 1 and 10, right? We are going to multiply these. If you are multiplying things that multiply scientific notation, I want you to write them in scientific notation. So I'm telling you now, no matter what the test says, this is how I want you to do it. You're going to multiply these, and then make sure that your final expression is in scientific notation. Okay, so this, for 18, we're going to simplify and write in scientific notation. If they're in scientific notation already, I shouldn't have to tell you that, but as I glance at these actually are not in scientific notation. I do want your answer to be in scientific notation. Okay, when we multiply numbers multiplied by bases of 10, numbers multiplied by bases of 10, or things that are in approximately scientific notation, we multiply this number times this number. And then we multiply the base of 10 by the base of 10. So we multiply 0.4 times 0.5 on your calculator, you'll get 0.2. So we put the big X, our base of 10. What's your exponent going to be on that 10? What's the exponent going to be on that 10? What are you thinking about? 10 to the 6 times 10 to the negative 13, that's like base times like base. What do we do with those exponents? No, power, up high, multiply. Add them, yes. So this would be 10, 6 plus negative 13. So 0.2 times 10 to the negative 7. Now, these are not in scientific notation, and neither is this one, because this number is not between 1 and 10, right? So our strategy for converting that to scientific notation, we're going to rewrite this in scientific notation. So some number times 10 to some power, and we're going to bring down this power of 10 that we already have in our answer. So is 0.2. So first thing we want to determine, is this going to be a positive or a negative exponent? And then we'll figure out what the exponent is. Is 0.2 less than or greater than 1? 0.2 is 2 tenths, right? It's less than 1. So if we have an expression that's less than 1, we want to write in scientific notation, that has to be a negative exponent. Less than 1 has a negative exponent. Greater than 1 has a positive exponent. Now, I go to wherever the decimal point is in this number, and I move it until I have a number that's between 1 and 10. Is 2 between 1 and 10? Yeah. If I move this one place, now I have 2.0, right? So that is 2, and I only move my decimal point one place. So now all I have to do is multiply my like bases again. 10, my base is at 10. So this is 2 times 10. What's the exponent on the 10 going to be? Negative 1 plus negative 7, right? Yes, negative 8. Any questions? All right, read the next problem. If you're not following along with me, you may want to follow along with me. I'm not playing. Number 20 will be a population density problem. So it will not be an excuse if you don't know what population density is, since we'll have 3 reviews with it on it. Y'all hearing me? If you're not following along with me or haven't been, you probably want to follow along with me now. So during 1 year, Costa Rica had a population of 8.45 times 10 to the 8th power of people. Any idea how many people that is? Do this on your calculator. Do 8.45 times 10 y to the x 8 equals. What do you get? 845. So maybe we have to put parentheses around something. So let's do 8.45 times 10. Yeah, that's not right. So let's do 8.45 times left parentheses 10 y to the x 8 right parentheses and equals. What do you get now? 8.45 and 6 zeros, right?
Yeah.
So that's 84 million, nope, like 845 million people, right? But that's written in scientific notation. Lee? I know. Now it says the area of Costa Rica is 3.25 times 10 to the 5th miles squared. So for population density, I'm telling you now, it is population divided by the area of the land. So the formula is population divided by the area. So the population is labeled with people, the area is labeled with some unit of measure, and it also says the area is. So the population, 8.45 times 10 to the 8th power, and it's divided by, it's a fraction, that's what the fraction bar means, 3.25 times 10 to the 5th power. So we divide these numbers and we divide these bases of 10. So we divide these in the calculator. We divide these by subtracting their exponents, or that's how we divide factors with like bases. Akira, are you with us or are you good? You doing this with us?
Huh?
Are you doing 20 with us or are you good?
I didn't do that.
Okay. So 8.45 divided by 3.25, what do you get? 2.6. Something like decimal point. 2.6 times 10 to the 8 minus the 5th power, so that's 2.6 times 10 to the 3rd power. Is that expression in scientific notation? Is this number between 1 and 10? Okay. Now, you should say 2.6 times 10 to the 3rd people per square mile, and you can do it just like that. I won't take off if you don't put that, but I will give you extra credit if you do, because it's important that you understand what this problem means, right? Not just the numerical part. That means for every square mile, there's 2.6 times 10 to the 3rd power. 10 to the 3rd power is 1,000, so that's 2,600 people in every square mile. And we have done the evens. So now you guys can work on the odds. Let me know if you need any help. Lee, if you need to use the bathroom, you can go now. Okay, Sean? Can you submit yours? No. Did you check it on Canvas yet? So the answers are posted in Canvas. Don't submit it in class before you check it. And then correct your problems.